All right, today we are going to play with Bluetooth. So create a new project. First, we're going to drag in the Bluetooth block. And let's go ahead and configure that. So first of all, we're going to alter it so that it's only on single core. We're not going to use the CM4 for this one. And let's go ahead and edit our GAT settings. So Bluetooth works by having services, and each service has a specific number of characteristics, and those characteristics can have certain things done to them. So we are going to create a service called device interface because it is going to interface our PSoC to the app on your phone. The custom descriptor, we don't need it. You can go ahead and delete that. Now this characteristic we are going to name device inbound because this will be used for any data that goes from the smartphone into the PSoC. And we're going to create one more, which will be used for sending data from the PSoC, which can be picked up by the smartphone. For inbound, we're going to set it to write because the smartphone will write a piece of memory on the PSoC. For outbound, we're going to do the opposite. We're going to create it as read so that the smartphone can read the memory off the PSoC. Now let's give this a name. Just use your own name so that it doesn't conflict with other people in the room. And for advertisement settings, we want this to be generally discoverable over Bluetooth. And just to make it easy, let's take the timeout off so that it is always advertising. The advertisement packet is what Bluetooth will broadcast to the world. And so you need your name, obviously. But let's also put in the service data so that anyone who sees this Bluetooth device will know what kind of services are offered by it. Great, a couple of things we need to set up. So Bluetooth Low Energy requires a precision clock. We need to use the WCO, which is an external crystal oscillator. And that will give us more precision in terms of what the Bluetooth needs. Next, let's configure our interrupts. So we are using the CM0 Plus instead of the CM4. At this point, we can go ahead and build. Let's start the software aspect of this. Let's create a variable just to store the data coming in and coming out. And this will be a function called the generic event handler. Now, the way Bluetooth works is that whenever an event happens, there's an event handler, and that event handler decides what to do based on that Bluetooth event. So we can see that our first case is BLE event stack on. This is essentially when the Bluetooth boots up and it's ready to start operating. And in that case, we just start advertising. Same thing if the Bluetooth is disconnected, which is the second case statement. You would want to start advertising. The third case statement is when the Bluetooth connects to your phone. Right now, we don't have this doing anything. We just break. However, you could do something like turn on an LED or run some piece of code. The last one, the CYBLE event gets write command, will trigger when the smartphone tries to write that characteristic we just created for the inbound characteristic. The next function we're going to create is Ble Interrupt Notify. Ble Interrupt Notify is called anytime Bluetooth needs the processor to do something. In main, we are going to start the BLE block, the same as we've done with, say, the PWM or the UART. Next, we will wait for Bluetooth to start up. So while CYBLE get state is not state on, we will keep calling process events. And finally, we are going to register the callback function, which is the Ble Interrupt Notify. In our main infinite for loop, all we're going to do is take whatever's in data and increment it by 1, and then write that to our outbound characteristic. We add a CY delay of 1000 milliseconds just so that there's some time in between so we can see the values changing. Let's go ahead and build this and program it. Now the CY Smart app you can get off the App Store. This just makes it easy to use the Bluetooth on your phone. So let's go into the service, and first let's read something. Let's read what's actually on there right now. It seems like it's been running for a while, so it's hex 7D. Let's try to go back and see if we can reset that back to, say, 1. So I'm going to enter 1, and let's go back and see what happened. Cool. So we essentially overwrote that data variable, and now it's counting from 1. Let's just set it to something else bigger just to see what happens. And you can see that it updated again, and it continues to increment.